very good morning to one and all. On behalf of the President of Children's Education Society and Chairman of the Oxford Educational Institutions, management, principal, deans, HODs and staffs, and students of the Oxford College of Engineering. I, Kavyapal, student of 3rd and EEE Department D. It is a great pleasure in welcoming you all for today's guest lecture on Advanced Driver Assistance System features organized by EEE Department. On this occasion, it's my great pleasure and honor to welcome our chief guest, Mr. Kushal, to this event to share his immense knowledge and experience. It's my great privilege to welcome our chairman, Dr. Aswin, Principal Dr. N. Kannan, Deans, Head of all the departments, staffs and students to the guest lectures. Mr. Kushal has done his Bachelor of Engineering in Electrical, Electronics and Communication Engineering from Bangalore Institute of Technology. He has done Masters in Engineering in Communication and Networking from Madras Institute of Technology Campus, Chennai. He worked as a graduate engineering in APTIV, Bangalore. Currently, he is working as ADAS, Algorithm Engineering in APTIV, Bangalore. His skills and interest includes modeling and simulation, agile software development, advanced driver assistance system, software development, programming, code generation, Linux, Visual Basic for applications, macro, test harness, requirements analysis, automotive spice, Jira model driven development, model design, model-based testing, MATLAB, Simulink, unit testing, C and C++. Once again, it's my pleasure to welcome you, sir, on behalf of the management, principal, deans and HODs, and all the faculty members and students of the Oxford College of Engineering. Over to you, sir.
Very good morning to all. So today's session is very informative and interactive. I hope so. Why should know? This is only the latest trend in our automotive system. So now you can see the 7th Sense students are having the elective of electric vehicles. Along that, sensors also one of the subject. So that you can get many informations on this. So which platform they are going to work means they just told MATLAB, Simulink and C++. In this, if you have some knowledge, you can easy to get inside the company. So without any programming skill knowledge, you cannot be do. So day by day, many kind of futures is coming in the automotive sector. So we no need to anything manually to operate. Everything is coming like in a sensor based operations only. Even for open your dicky also, just you can be shake your hands, it will be get open, and your wipers have to work means automatically. If you can put one bottle of water in that windshield, immediately the wiper will be switched on. How long time it have to be switched on means that is also will be sensed by the sensors only. So water continuous falls on windshield and it will be work. And the dim and dip, that is the headlights. That is also the vehicles comes with that should be captured by the vehicle only with the smart cameras. Automatically dim and dip it will come. So now as of now, any turn light left, we are never going to put the signal. Automatically with the steering only it will be connected. After some turn of rotation, it will be switch off that indicator. Like many, if example air condition, so like roof opening, many different applications are there. This seminar definitely very much useful to you. So kindly utilize this kind of opportunities and what you want to do. Many times we will tell you have to do some value added courses, which courses have to do, you will definitely will be find difficult. But this kind of lectures will be helpful to you to find where you have to be concentrate, what kind of the course have to be do. Okay, once again wish you all the best. Kindly take this session effectively and usefully. Thank you. Yes, sir. Okay. Thank you. Yes, sir.
Hands on, right? Fifth sem, okay. So, everyone has any idea about automotive systems or ADAS features? Any general idea? No. So, any general idea about automation in vehicles? So, this needs to be an interactive section. So, if you don't know something, you can just let me know. I can explain. So, if it is an interactive system, it will be much useful. Mainly about advanced driver assistance system, that is ADAS. So, what is ADAS and where it is used and what are the basic in this industry? So, this is a very large market industry. So, all the automobile dealers, so every car, trucks, mainly cars and mostly trucks, everything is part of this industry. So, everywhere the current trend is moving forward automation. So, in automation, so it greatly improves the safety. So that's one of the main deal we are moving forward automation. So few years back, like 10 years back, government made all the airbags mandatory for every car. So that's also an improvement for safety. So our goal across the entire industry is moving toward a greener safety. So that's one of the main goal of this industry. So let me start the session. Okay. So till now you have any questions? So anything you need to ask or any more points which I need to explain about the general of this basis of these features and systems? Any questions? So okay, let's start now. So ADAS feature is basically a ECU, so which automates, which controls lot of sensors. So sensors such as ultrasonic sensors, you may be aware of the ultrasonic sensors, and such as radars. So radars not only used in aeronautical field, in automotive field also we use radars. So automotive radars will be small in size and it will be long range. It is very easily portable. So, and one of the, like I mentioned, one of the main goal is to improve the safety of the autonomous vehicle. So, for example, if all the vehicles running in the world incorporate this system, so say a number of accidents will greatly reduce. So, most of the accidents is caused by the human fault. So most of the cases it will be human fault. So that can be easily. So this is just industrial standard ECU. So ADAS is a software. So we have to install the software into a ECU. So just there are like Arduinos, right? You are aware of Arduinos, right? So you will do the C++ program and install it into the Arduinos, and Arduino will function as per your program, right? So similar to that, we have all the industrial standard ECUs. So everything in this ECU will be automotive grade. So Arduino is you cannot use for longer period and it will break after some time. But all the ECUs used in the automotive industry will be of automotive grade. Should be of automotive grade. That's one of the government norms that is imposed. So they undergo rigorous testing and they need to function in all temperatures. So those are there are like lot of requirements for the sensors needs to be meet automatic. So let's see what are the main types of sensors used to be. So if you see here, this is ultrasonic sensor. So first you can see the image. So this is an industrial grade automotive sensor used in automotive. Every trucks, cars, whichever uses ADAS feature, uses these type of sensors. So first is ultrasonic, and next is mostly radars and cameras and lidars. So these sensors will be very dust resistant. So it will have like more than a lifetime of 20-25 years, and it will perform in very high temperature as well as in very low temperature. It can function till -5 degrees Celsius, and similarly at a high temperature as well. So that's so this is very much needed because a car needs to run everywhere. You can take a car and you can go to a hill station or even the polars. The car needs to function. So the sensors needs to be automotive grade. And other than that, these sensors will have good precision. So the sensors, ultrasonic sensors which we get in the market for your projects and all. So those sensors will be a normal grade. So that doesn't have a long life and it may give inaccurate inputs and outputs. So there is a chance of inaccurate data. So that cannot happen in the ADAS system, because this ADAS system saves lives. So if something goes wrong in these sensors and if the input was wrong, that will actually seriously affect the end user. That is, if you are driving a car, if something goes wrong in the sensor, it will greatly affect your input, and the deployment of the features will be affected. So we will see more about features in coming slides. So mainly ADAS is divided into two types of features. Feature-wise division will be two types. That is, one is active ADAS features and other one is passive ADAS features. So active means you will get all the inputs from the sensors. So sensors such as radars and ultrasonic and lidars and cameras. So these are the major sensors. We will be getting all the inputs. Once we get the input, we will process the input. So based upon the input, we can get all the distance, or from camera we can get the detections. So like for example, if there is a in the road, if there is a passenger walking by, we can easily detect it's a passenger or system code. So most of the accidents, one of the major reason is if something goes wrong, people will panic and they will freeze. So they cannot react in proper time. So that's the reason most of the accidents happen. So to overcome this, active ADAS features will take over the control of the car at an emergency situation. So similarly, passive ADAS features. Passive is nothing but you will get all the inputs, but we will only give the warnings. So we will, if we are, for example, if a car is going to turn right, if there is some obstacle there, we will give a warning to the driver, there is an obstacle, don't turn. So similar features comes under passive ADAS features. So why we are here to So what are the benefits of using ADAS systems? Like I mentioned, one of the main important thing is safety, and other thing is driver can ride freely. In for example, there is a long distance travel, driver can ride very chill, because there is a emergency system or a ADAS level 2 system controlling the car, which will actually greatly improve the stress, and it is also great convenience. So about the more feature we will talk in the upcoming slide. So this is one of the vehicle architecture. So you can see what where the sensors are mounted. So the radars are mounted at this point, and similarly at both the sides, both the bumper end, radars will be mounted. And for lidar, it will be mounted in the little bit above. Similarly for camera, there is surround view camera. So most of the cases, surround view camera will be used for 360 degree view. So each and every side we will have an eagle eye camera. So that will have by having the camera, we will get a good 360-degree view of the entire car. And forward-looking camera will be mounted in the windshield. So this will detect all the pedestrians or lead vehicle, that is vehicle ahead of you. So those type of detection will be done using this camera. And driver monitoring camera. So this driver monitoring camera is basically to monitor driver in long distance travels. Some driver may sleep, fall asleep or tired or fatigue. So any of these may affect the performance of driving. So to monitor driver and give warnings to the driver. So warnings may be of a lot of types. Like audible warning, dashboard warning, there is such video warning. And other than this, you can have a vibration sensor in steering or in under your seat, and the vibration will wake up or give a jerk to a driver. So that way, it will also greatly improve the driving experience. So this is our surround view camera, and at this end of the rear bumper, we will be mounting two short range radars. So to have a detection at the rear end of the vehicle. Similarly, front view camera. So at the most of the cases, this will be mounted in this part. So that depends upon the vehicle design. For some cars, it may mounted at the back of the vehicle. For most of the cases, it will be mounted here. So this is the central module. So this module is basically, in the simple terms, you can say as the CPU. For if you have a monitor, you have a keyboard, you have a mouse. So keyboard and mouse are input devices, and you will those input devices will be getting input to CPU, right? So basically, the entire CPU is the ADAS control module. So basically, it will get input from all these sensors. So most of the inputs are coming out of these sensors, and this ECU will do the process. So. Any questions till now? Basic ADAS architecture. So, like I mentioned, these are the items will be present inside the ECU board. That is ADAS ECU, and this will give warnings to a driver, and like all the inputs, camera, radar, navigation, and other sensors. So, when going, most of the cars will be, the latest cars will be having, and higher cars will be having navigation. So this navigation is, in the sense, it's not a simple navigation, so it's not similar to a mobile GPS. It's a HD map navigation, so that's completely different. So HD maps is what is previous HD cars, they will have HD cameras and HD radars and HD lidars, and they will map the road. So this will be done currently. It's very latest trend into the market. This will be done. These are done in few European countries and US. Few countries they have done it. So they will map the entire road. So they will map the entire road even at the with the centimeter level access. So they will have the roads of all the details of the entire road, and with respect to the road, using the GPS, we can navigate at which exactly lane. Even the lane will be properly mapped. So if you are in first lane or second lane or third lane in the particular highway, so that can be even clearly mapped. So this will take. These are the active controls. So what it will control is brake system. So and steering system, basically electronic suspensions. So if we are going on off-road and we need to improve our riding performance, so it can automatically adjust the suspension based upon we will get how much height we are in the off-road and how much those details will be getting. We will get it from radar. So radar will be giving good measurements about distance and speed. So using that we can automatically adjust the suspension. Similarly, powertrain. So powertrain is a part which transfers the torque or force from a engine to wheels. So that part. So how much torque you can give, how much you can see in this video. Radar will detect the distance between current vehicle and the lead vehicle. So once user sets a particular distance, if the lead vehicle slows down, we will be doing automatically slowing down. We will be taking over the brake and we will automatically slow down. And if the lead vehicle moves fast, we will be acceleration and we will be catch up to the lead vehicle. So if we say 10 meter distance between these two vehicles, you will always maintain 10 meter distance. So this needs no user input is needed. You can just simply sit in your driving seat and see. It will automatically take over the brakes and acceleration, and then it will do the feature. So one note is most of the cases where ADAS active features, that is when it is taking over acceleration or brake, we will be having automatic gearbox, not the manual. So everything will be automated. This is one of the adaptive cruise control feature. So any doubt? Any questions here from this side? Okay. Everyone got? Okay, so let's moving on. So how these features work? Like I mentioned, the radar will be mounted on the front, right? So that calculates the distance. So radar is good at calculating the distance. So up to 250 meters, up to 300 meters. So before they from the vehicle, ego vehicle, that is the host vehicle, to 300 meters, we will get an accurate distance for every 5 milliseconds. So for every 5 milliseconds to 10 milliseconds, we will get the distance. So when it calculates the distance and when we send it to the control ECU, the control ECU will decide is this the distance which we need to maintain, or if not, this is the distance which we need to maintain, we will give the acceleration and the vehicle will move forward, and then else we will put the brake. So in the when going for automation, each and every part of the car, similar to accelerator and brake and even gear, everything will be automated. So in this case, brake will have a separate ECU for it, so separate control unit for it, and acceleration will have a separate control unit for it. So everything will be interlinked. So we just request brake ECU to apply the brake of this much amount of torque. So when applying brake you can't apply at a very hard when you are getting a very slow deceleration. When you need a very slow deceleration, you have to apply with a specific amount of torque. So that is very and similarly for acceleration. So the level 2 plus feature. So when you are in a parking lot, so this will be working in a specific highly designed parking lot. So the lane markings should be there. So these type of lane markings people follow. Camera will recognize all the objects. So if you see here, camera recognize the pedestrian and the surface area occupied by the pedestrian. And similarly, the parked cars. So these are already parked cars, and this is an oncoming traffic. Similarly, recognize everything. Camera will recognize what is. So camera cannot recognize. Camera is not good at, can do, but not good at measuring distance. So if the distance here will be probably 1 meter. So camera it will say it's 1.5 meter. So it's not at all accurate in measuring distance. But radar or ultrasonic sensors, those will be very good at measuring distance. So they will even have at the millimeter level accuracy. So what it does is first the sensor scans for parking spaces. So when scanning, radar can penetrate through objects. So if a camera is blinded, if you cover the camera, it's then camera is out of order. So in the case of radars, it is it can penetrate to objects. So even from 250 meters here, even there is a wall, we can measure what are the objects present, how many objects are present in that side of the wall. So using radar. So that way it will scan the entire parking lot, and you will get a once it finds the free space, there is a parking space. It will automatically apply acceleration, brake, and steering angle. So how much steering it needs to turn, and those everything will be automatically calculated by the algorithms, ADAS algorithms. And then we will be parking at a specific place. So let's see a quick video for this. So here it finds a parking space in here. Once that is found, it automatically parks the car. So this scenario can be applied when in narrow parking. So most of the cases people are afraid of narrow parking. So there will be a car parked in front of you and car parked in back of you. You have to park in between. So we have seen a lot of issues happen, lot of fights and lot of accidents happen because of this narrow parking. So in that case also we can use this auto park assist feature to park the car automatically. Yeah. This is the architecture basically of, so very basic structure of how the auto park feature works. So you will be detecting pedestrian or car or truck using camera, and you will have a radar here. You will have the radar here. So radar can detect if there is a chair here, means it cannot detect it's a chair. There is something here at this particular distance. So it is it can detect the distance very proper. So even to a millimeter level accuracy. So that's the radar very good. So what we do is we take the input from camera that this is a chair, and we take input from radar. This is at this many distance. Once both the inputs we get, we do the fusion. This will be done at the ADAS ECUs. They will do the fusion, and once it will go to the control ECU. So basically, it will be a form of single ECU only. But single ECU will have all these components. So that will decide how many brake needs to be applied, how much acceleration and how much steering needs to be applied. So these steering, acceleration, brake, so these are like this how much needs to be applied, right? So that entirely depends on how much tire pressure you have, how much suspension is, how much height suspension is applied. So those additional parameters needs to be included when doing the calculation. So this is one of the features. So any questions till now? No questions. Any questions? Okay. So next is lane keeping assist. So these are already implemented features. They are running in production cars. So for example, most of the features which I mentioned here now, those are highly implemented, and in few European countries, few of the features I mentioned is mandatory. So without having these features, you cannot release a car in European countries. Similarly in US also. And so lane keeping assist will be the main input we are getting in lane keeping assist from is camera. So camera will be mounted in the windshield, above the windshield. So it will detect all the lanes. So these white markers, right? So these white markers will be detected, and radar will detect how much there will be a road ends, right? When road ends, there will be a objects, most of the end objects. It will detect all the end objects. And here, so radar will detect all the end objects, and it will camera will detect all the lane objects. That is the lane markers. So from that we can easily triangulate where the car needs to be positioned to follow the second lane or first lane. So this is the major input in this. So let me play a video on this. So if there is a oncoming traffic also, we can slow the car so that it does not hit other vehicles. And if the car moves like this way, we will downwards or upwards, we will adjust the steering angle, and steering torque is applied, and once that is done, you can easily move back to the original position. So everyone is getting what I am trying to say?
Yes, sir.
Yeah? Everyone understood, right? There is still no question. So that depends upon the feature. So if you want to apply the emergency brake, you can apply the brake. Yes, system will do it for you. So if you are going to hit, so in some cases you are going in 120 km/h and you are trying to apply the brake. You are in fear, you may not press the brake hard. So brake torque will be not enough. So in these cases, system can easily predict that you are going to hit for sure. So in that cases, it will apply more torque in braking. So if it applies more torque in braking, you can easily stop the vehicle before hitting the target. So mostly these two radars will be used in this feature. So if we are going at very high speed, and once we reach an intersection, once we reach the intersection, if some vehicle is coming here at very high speed, so what will happen? There will be a collision. So to avoid this collision, when we came here itself, we will detect there is some objects coming. So using camera, we can detect it's a car. Then these detections, right? This will be happening every 5 milliseconds to 10 milliseconds. So at a inside a single second, the number of time you can